Welcome to my class. I'm Drew Collop. In today's class, we're going to continue our discussion of solving quadratic equations. In our previous lecture, we looked at our techniques of factoring to solve quadratic equations. Factoring cannot be used with every quadratic equation to solve it. As a result, there are other techniques involved. In today's class, we'll talk about completing the square and the quadratic formula. Let's discuss completing the square first. If we look back to example 2D from the previous lecture, we found an equation like this. Y is equal to x plus 2 squared minus 9. We found it was very easy to solve. Remember, when solving a quadratic equation, you set y equal to 0 and you're solving for x. We swung the 9 over to the other side. We had a squared value there. To get rid of the squared, we took the square root of both sides. After the square root, we have x plus 2 equals the square root of 9. Lastly, we have x is equal to negative 2 plus or minus the square root of 9. You can see we're going to get two answers for this. Square root of 9 is going to be 3. So negative 2 plus or minus 3. I'm going to leave it in this format for now. The reason why this was easy to solve is because it contained a perfect square. This can be broken down into x plus 2 and x plus 2. The technique of completing the square takes a complex problem and creates a perfect square trinomial. After that's done, it's quite easy to solve. If I take that same equation, I expand it, FOIL it, and I drop the brackets, you can see this is what we get. These two equations are exactly the same. The one on top is much easier to solve. So what we're going to do, we're going to turn this into this. This is what completing the square does. Completing the square is not the easiest technique to learn. There are a number of key factors here you have to understand. I'm going to go through them now. So let's examine what happens when we have a perfect square trinomial. So that's what we're looking for. We're trying to find a perfect square trinomial. You have a perfect square trinomial if the first and the last terms are perfect squares. You can see the first and the last term in all three of these expressions are perfect squares. You also have to have the middle term has to be twice the product of the square root of the outer terms. That's wordy. Let's explain what that means. So the middle term, this term here, has to be twice the product. So I'm saying 2 times the product. I'm multiplying two things together. The product of what? The square root of the outer terms. So this would be a 1, square root 1, and this would be square root of 4. 2, 1 times 2, which is going to be 2 times 2, which is 4. As you can see here, this one is a perfect square trinomial. Examine the other ones. We want twice the product of the square root of the outer terms. 2 times 5 is 10. Yes, we want twice the product of the square root of the outer terms. 2 times 9, which is 18. So you can see these are all examples of perfect square trinomials. As a result, we can quickly factor those, and we can remove the squared by square rooting that. We're going to do that later on. If I go back to this one here, what we're going to do, we're going to take the second degree term and the first degree term, and we're going to add a constant to that to make it a perfect square trinomial. The question is what number do we have to add to make it a perfect square trinomial? Let's examine that now. So to determine what constant should be added, and you're always going to add it, let's examine the steps to find out the coefficient we need to add to make these all perfect square trinomials. Step number 1, we take the coefficient on the first degree term. So let's look at 1a. We're taking the coefficient on the first degree term. We then divide this by 2. We then square this value. Negative 6 divided by 2, negative 3, and squared is equal to 9. So this will be 9. Notice we're always adding it. Why are we always adding it? Because we're squaring it. No matter whether we have a positive or a negative value inside those brackets, because we're squaring it, it will always be a positive value. After we do that, we can factor this into x minus 3 squared. We look at the minus 3. Minus 3 times minus 3 is positive 9. Minus 3 plus minus 3 is minus 6. So here you can see we take that middle coefficient, and in the end, we determine what that constant will be, and we add it on. Let's try it for these ones now. Take the middle coefficient, divide by 2, and square it. Negative 4 squared equals 16. I'm going to add 16 to that. I can now factor it. X, the value is going to be 4, but it's going to be negative 4. Why? Because that's a negative sign right there. Negative 4 plus negative 4 is negative 8, and negative 4 times negative 4 is positive 16. Let's try the last one now. Again, take the middle term. 2 divided by 2 squared equals 1 squared, which is equal to 1. So here when I factor it, x and 1, it's going to be plus 1, because again, it's a positive sign right there. So you can see we take those middle terms, we divide by 2, and we square it. In the end, we get a constant we can add to create a perfect square trinomial. And then it's quite easy to factor it. Let's solve this quadratic equation using the completing the square method. So I'm going to take these values here. Take that first degree term, 6, divide it by 2, and square it. 3 squared, which is 9. So what I'm going to do is I'm going to take x squared plus 6x. I'm going to add to it 9. I have now created a perfect squared trinomial. However, I cannot just add 9 to an equation. I can do that if I also subtract 9. These two are now equal. What I'm going to do now is I'm going to keep my perfect square trinomial on one side and move everything else to the other side. I am then going to factor that perfect square trinomial. X plus 3 squared is equal to, combine those together, is equal to 3. Now this is quite easy to solve. To get rid of the squared, I square root both sides. X plus 3 equals plus or minus the square root of 3. Isolate x on its own, negative 3 plus or minus the square root of 3. So here's your answer. Notice there will be two answers. Sometimes when you're working with assessments online, this would be the final answer. X is equal to negative 3 plus the square root of 3, and x is equal to negative 3 minus the square root of 3. But of course, that's going to be a number. Let's work that out. This one will work out to negative 1, 2, 6. A lot of decimal places here. Remember, don't round off till the final answer. However, this is the final answer. Let's round off to, say, 3 significant digits. Just because I said so. The other one here, we get negative 473. Round that off to 3 significant digits, negative 4.73. Now we have 2 correct answers. We've solved this by completing the square. Again, let's review the steps. Step number 1. We look at the coefficient on the first degree term. We divide that by 2, and we square it. This value becomes the constant we add to create a perfect square trinomial. When we add it, we also have to subtract it so we don't change the value. Keep all the terms that create the perfect square trinomial on one side, move everything else to the other side, the other numbers. Square root both sides, and you will solve this quadratic equation. Sometimes your coefficient on your first degree term is not a 1. This technique only works if that value is 1. So you need to make 2x squared into 1x squared. How do we do that? We divide everything by 2. x squared minus 1/2 x minus 3 equals 0 divided by 2 is just 0. Next step, we take that coefficient on our first degree term. It's negative 1/2. I'm going to divide by 2, and I'm going to square it. Remember what happens when we divide a fraction? We flip it and we multiply it. This gives us negative 1/4 squared, which when we square it is 1/16. So here, to turn this into a perfect square trinomial, I have to add 1/16 to that. So I don't change the value, I have to subtract it as well. These things are still equal. But now I've created a perfect square trinomial. Let's keep that here. And let's swing everything else to the other side. Positive 3, positive 16. We'll now factor that perfect square trinomial. X, square root of 1/16 is 1/4. It's going to be negative. Why? It's a negative sign there. Negative 1/4 plus negative 1/4 is negative 1/2. Over here, let's turn that into a common denominator of 16. 16 times 3 is going to be 48. We'll then square root both sides to get rid of that squared value. We get x minus 1/4 equals 49/16. And we're taking the square root of that. Let's isolate x on its own by swinging the 1/4 to the other side. It comes positive 1/4. We're going to square root this. Notice, look at this. Square root of 49, 7. Square root of 16 is 4. Here's your answers. X is equal to 1/4 plus 7/4. And x is equal to 1/4 minus 7/4. Very convenient. We already have them with common denominators. 8/4 is equal to 2. And this one is 1 minus 7 minus 6/4 minus 3/2. So there are two correct answers to this one, 2 and minus 1.5. Now with this particular equation, we could have solved this as a complex trinomial, right? We're looking for two numbers that multiply to negative 12 and add up to negative 1. That would be negative 4 and positive 3. We would decompose that value into 2x squared minus 4x plus 3x minus 6 equals 0. Common factors. Two x plus 3, x minus 2 equals 0. So in the end, we get 2x plus 3 equals 0, and x is equal to 2, and x is equal to negative 3/2. So for this particular question, we can solve this either by completing the square or by factoring. Hopefully you can see factoring is much simpler. However, factoring will not always work. Sometimes you will require other tools to solve these quadratic equations. Completing the square will always work. I would like you now to try example 4 on your own. There should be two correct answers to this. Let's say round this off to 3 significant digits. Try that now. Let's now take it up. Remember that coefficient on my second degree term has to be a 1, so I divide every value by that. This gives me x squared plus 5/3x plus 1/3 equals 0. Now I want to use these terms here, and I want to complete the square. So I'm going to take this value here, 5/3, I divide by 2, and I square it. This will give me the constant I have to add. (25/36) is the constant I need to add. X squared plus 5/3x. I'm going to add 25/36. I'm also going to subtract 25 over 36. Don't forget to include the constant that's already in there. This is now a perfect square trinomial. So I will keep that on this side and swing everything else to the other side. Let's now factor this. Square root of 25 over 36 is going to be plus. Why? Because that is plus. As a double check, what we could do, we could add those values together. 5 over 6 plus 5 over 6 is going to be 10 over 6, which is going to be 5 over 3. You can see we get that right there. Let's combine these fractions together by getting a common denominator of 36, and that's going to be what? 12. In order to get rid of the square root symbol, we're going to square root this side and do the same thing to the other side. X plus 5 over 6 is equal to, combine those together, 13 over 36 square root. Isolate x on its own by swinging the 5 over 6 to the other side, becomes minus 5 over 6. Notice this, plus or minus, I can take the square root of the 36 is going to be 6. And look at, I have a common denominator. X is equal to negative 5 plus or minus 13 over 6. Now, of course, I'm going to get two answers here. X is equal to negative 5 plus 13 over 6, and x is equal to negative 5 minus 13 over 6. When I work that all out, I get negative 0.232400812. Round that off to 3 significant digits. X is approximately equal to. Do the same thing down here with the negative one. Let's say round this off to 3 significant digits. We get x is equal to negative 1.43. So we think back to our possible solutions for quadratic equations. Quite often you'll get two correct answers. Sometimes you'll get one, but remember sometimes as well you'll get no correct answers. No solution. Now that we've worked through completing the square, I'm going to apply that to a generalized quadratic equation. So here I'm just going to place in there a, b, and c as my values. And then I will solve this by completing the square. Remember, the value on our second degree term has to be 1, so I'm going to divide everything by a. When I do that, I get x squared plus b over ax plus c over a is equal to 0. I'm going to use these two terms. I'm going to complete the square. So I take my term here, b over a, divide that by 2, and I square it. And we will use that to complete the square. We add that, and we subtract it. We now have a perfect square trinomial. We'll keep that on one side and move everything else to the other side. We'll then factor the first bit, x. Square root of b squared is b, square root of 4a squared is 2a. And we're going to be adding it. We want to combine these together here. Got to multiply that by 4a, got to multiply that by 4a, so we get a common factor of 4a squared. Again, to get rid of that squared, we're going to take the square root, do the same thing to both sides. Combine those together. Isolate x on its own by swinging the b over 2a to the other side. Take the square root of this, and we can actually take the square root of 4a squared, that's 2a. Notice we have the same denominator here and here. Let's combine those together. Now I ask you, does that look familiar? It should. This is your quadratic formula. So I'm sure you've seen this before, but I wanted to show you where it came from. I took a generalized quadratic equation, and by completing the square, I derived the quadratic formula from that. I will not be asking you to derive the quadratic formula, but I think it's important that students see where these things come from. They don't just magically appear. This is an equation that you should memorize. I will not be giving you this formula in a test. You are expected to know it. So this leads us to technique number 3 when solving a quadratic equation. So our first technique was factoring, our second technique was completing the square, and our third technique is using the quadratic formula. Factoring only works some of the time. Completing the square and the quadratic formula work every time. I find the quadratic formula much easier to work with. When I'm solving quadratic equations, quite often I'm only using technique 1 and technique 3, factoring and the quadratic formula. Let's examine the quadratic formula now. Let me point some mistakes students make when they work with the quadratic formula. First of all, oftentimes they don't write that there. They just write the equation like this. But remember, x is equal to. You need to have that in there. If you don't write that on an assessment, x is equal to, I'm going to deduct marks. Make sure that's in there. Also, students forget that negative b is there. I'll show you what happens in a minute, but quite often, if b is a negative value, they forget a negative times a negative makes a positive. Lastly, quite often students, they eliminate that part of the fraction. Please notice, this is one large fraction, the whole thing. Sometimes what I see is students write b plus or minus the square root of b squared minus 4ac over 2a. This is incorrect. You need to extend that. That's a different equation than that. So make sure you treat it as a numerator over a denominator. Let's now use that to solve some quadratic equations. Example 6, you don't see the coefficient, it's 1. So here a is equal to 1, b is equal to, if there's a negative sign, it comes along for the ride. So those are our 3 values there. Let's sub them in. X is equal to negative b. Again, this is where students mess up sometimes. They see the negative b and they forget it's negative b. Very important. Plus or minus b squared minus 4 times a times c, square root the whole thing. And make sure when you square root it, you write it all like that. I see some students do this. That's incorrect. Make sure it goes over all those terms. Divide that by 2 times a, which is 1. Negative times a negative is a positive. 36. Negative 4 times 8 is negative 32. X is equal to 6 plus or minus 36 minus 32 is 4. I can work this out. 6 plus or minus 2 over 2. So I get x is equal to 6 plus 2 over 2, and I get x is equal to 6 minus 2 over 2. 8 over 2, which is 4, and I get 4 over 2, which is 2. So you can see the solution to this quadratic equation, we get 2 correct solutions, both 4 and 2. Let's try example 7 now. I'm going to show you something that's wrong here. I see this happening all the time. Students, they say, oh, I know how to do this. Take out a common factor, and then we'll make x equal to minus 7, and we'll make x plus 10 equal to minus 7, and x is equal to minus 17. 2 correct answers, right? Wrong. Can't do that. Why can't we do that? We can only break it up like that if this value is 0. If it's anything else, We cannot do this. So please don't do that. How we solve this is we rearrange it into this format. X squared plus 10x, swing the 7 over to the other side, becomes positive 7. Now we solve it. X is equal to negative 10 plus or minus 10 squared minus 4 times a times c. Divide all that by 2 times a. Negative 4 times 7 is negative 28. The square root of 72 is not a whole number, so I'm going to write this as x is equal to negative 10 plus square root 72 over 2. And I'm going to write this as x is equal to negative 10 minus the square root 72 over 2. We'll work that out, solve for 3 significant digits. Which rounds off to 0.0757. X is approximately equal to that. Down here, negative 9.2. Round that off to 3 significant digits. Negative 9.24. So again, we've solved this quadratic equation and we get 2 correct answers. Example 8. Again, let's rearrange it first. Then we'll solve. Negative b plus or minus b squared minus 4 times a times c squared root, the whole thing divided by 2 times a. Positive 6 plus or minus 36. 4 times 9 is 36, so I'm subtracting 36 over 18. Notice what happens here. This is an example of a quadratic equation with only one solution. 1/3. I would like you to try example 9 on your own right now. Solve this using the quadratic formula. Let's take it up. X is equal to negative b plus or minus b squared minus 4 times a times c square root over 2 times a. X is equal to negative 10 plus or minus 100 minus 4 times 25 is 100 times 2 is 200 over 4. Negative 10 plus or minus 100 minus 200 is minus 100 square root over 4. X is equal to negative 10 plus or minus... what happens now? Square root of a negative number. No real roots. If you get this, this is the example of no solution to this quadratic equation. Remember, there are 3 possible solutions you can get to a quadratic equation. 2 solutions, 1 solution, or no solution. So whenever you have to take the square root of a negative number, this will represent no solution. What you can write is no real roots or no solution, and that is the end of this question. We will not be working with imaginary numbers in this class. Let's now look at example 10. Hopefully you notice you've seen this one before. This is the question we had during our factoring of quadratic equations that I said we couldn't solve because we didn't have the necessary skills. Well, guess what? We do now. Let's work this out. We have an equation, height is equal to negative 16t squared plus 25t plus 50. The question is, how long will it take for the object to hit the ground? Let's draw a little diagram of it. Here's our height. When it hits the ground, height will be 0. And there will actually be 2 answers to that if we threw it from the ground. So let's set h equal to 0, and we will solve it. Remember, we tried to factor this. We were looking for two numbers that multiplied to minus 800 and added up to 25. And we couldn't do that. Therefore, there are other techniques such as completing the square and the quadratic formula. Let's use the quadratic formula to solve this. So in this case, t is equal to, because t is our variable, not x, t is equal to negative b plus or minus b squared minus 4 times a times c, and I'm going to take the square root of that whole thing. I'm dividing that entire top part by 2 times a. So there'll be two correct answers to this. T is equal to negative 25 plus this large square root divided by negative 32. And t is equal to negative 25 subtract the square root of this number divided by negative 32. There are two correct answers here. However, one of them is negative. So we will say this one is invalid. The question says round off to the nearest thousandth, tenths, hundredths, thousandths. So this gives me t is equal to 2.714. Units are seconds. Therefore, the object will hit the ground after 2.714 seconds. We used our quadratic formula to solve this. I just want to go back for a second and look at that negative value. Where is that value coming from? Let's look at this diagram. Time here, this would be at 2.714 seconds. This here would be a time of negative 1.151 seconds. Now, normally when we're throwing objects, we're not on the ground. We throw it from here. So this is extrapolated backwards. Based on the arc, it might go backwards and hit the ground behind you. So this is what this negative time might represent. However, quite often we're not looking at negative time, we're looking at positive time. So therefore, there's only one correct answer. To examine questions like this further, you'll look at this in physics class. Physics is just applied math. Before we finish this class, we're going to discuss one more topic, something referred to as the discriminant. Inside the quadratic formula, it will tell you how many real roots you get by looking at the discriminant. The discriminant is this part in the quadratic formula that's inside the square root symbol. Remember, we looked at this. If this value is a positive number, you get two answers. If this value of the discriminant is 0, you get one answer. If that value inside the square root symbol is negative, you get no real roots. Why? Because without imaginary numbers, you can't take the square root of a negative number. So just by looking at the value of the discriminant, that value inside the square root symbol of the quadratic formula, we can tell whether there's going to be 2, 1, or no solutions to this problem. I'd like you now to try example 11 on your own. To do this, sub those values into the discriminant and tell me how many solutions there will be. Try that now. Let's take this up. All that matters is whether it's positive, negative, or 0. So this is going to be 400 minus 24. We know this is going to be a positive number. Doesn't matter what the number is. It's positive. Therefore, there are 2 real roots. Look at the next one. equals minus 23. Again, it doesn't matter the number. All that matters is whether or not it's positive, negative, or 0. So it's a negative. Therefore, there are no real roots. We'd be taking the square root of a negative number. Finally, with C, double check here. Y is equal to 5x squared plus 10x plus 5. How many of you didn't do that properly? Always double check to make sure they're in the right format. We'll sub this in now. And we get this equal to 0. So this is equal to 0. Therefore, there is one real root. So once again, the discriminant is just that value inside the square root symbol. And it can tell you how many solutions you'll have to the quadratic equation, whether it's 1, 2, or no solutions. There's a number of practice problems here, 1 through to 8. And as always, here are the answers to those practice problems. Give these a try on your own. I'm not going to take any of them up during this lecture, but I'll take any of them up you would like during tutorial, or you can contact me outside of class. At this point, we've covered all the content for factoring and solving of quadratic equations. You will require to know this content for your next math class. Your next math class, you will discuss logarithms, statistics, and calculus. You'll have to really know your factoring for calculus, specifically doing first principles. In our next lecture, we're going to move towards more applied math. We're going to apply these mathematical concepts to the laboratory. We'll discuss measurements and conversions. Conversions are very important. Specifically, stoichiometry. Those are chemical conversions. We'll examine applied percents, percent air, percent yield, and percent concentration, as well as molarity. We'll discuss dilutions, serial dilutions, and standard curves. These are all techniques that you will use throughout your career in the laboratory. That's all for today. Until next time.